Good evening, everybody. My name's Jen Mburu. I'm in the Data Analytics Bootcamp, and I'm going to be presenting my capstone. And the title of my capstone project is Money Matters, Exploring the State of Financial Well-Being in the United States. So the data set that I used for this capstone, I obtained it from data.gov website, which was a survey that was conducted by the Consumer Financial Protection Bureau. They wanted to understand what financial well-being entails. And according to their definition, they defined financial well-being as a state of being wherein a person can fully meet their current and ongoing financial obligations. They can feel secure in their financial future, but also they're able to make choices that allow them to enjoy their life to the fullest. Now, financial well-being is not something static, it's dynamic, and through education and also everyday opportunities, you can transform your financial well-being and move along the continuum. The purpose of this capstone was to analyze the data set that I had, which contained 217 columns and 6,394 rows. I wanted to analyze factors that influence financial well-being, develop a machine learning model that could predict an individual's financial well-being, and also provide insights and recommendations for future purposes. The cautions that guided the direction of this capstone revolves around how demographic factors, individual beliefs, and knowledge about financial concepts influence financial well-being scores, as well as how can we, develop a machine learning model that integrates both demographic factors and knowledge about financial concepts to accurately predict individuals' financial well-being score. Now, for this capstone, I did use Python, where I extensively relied on VS Code. I did use SQL through my SQL Workbench, and Excel, and also Power BI. While using Python, I did use these libraries. I did use Pandas for my data cleaning, Matplotlib and Seaborn for data analysis and visualization, and scikit-learn for machine learning model development. While I was doing, exploratory data analysis using Python, I did create several scenarios, and I'm presenting those the scenarios outcome using visualizations. This is a histogram that I created that showcases the distribution of financial well-being score. It's normally distributed with a mean of 56.08 and a standard deviation of 14.06, which is a huge standard deviation for a mean of 56. This is a histogram for financial skills distribution. It's normal, but it's slightly skewed to the right. It has a mean of 50.78 and a standard deviation of 12.252. Again, the standard deviation is slightly larger for a mean of 50.78. This one is a scatter plot that I created for financial skills against financial well-being. I wanted to understand how the two features correlate with each other. And from a naked eye, you can see, one can assume that the two are strongly correlated. But if you calculate the Pearson R, which gives us 0.49, you will come to realize that actually there is a moderate correlation. And this can be attributed to the higher standard deviations that we saw in the two previous histograms. In order to answer my first question, which was about how individuals' knowledges and beliefs about certain financial concepts affect individuals' financial well-being, I did create several scenarios, but for the case of this presentation, I'm only going to touch on this one, which is a chart that shows financial well-being by mortgage term interest. Again, this was a question that was asked to the participants regarding the differences between a 15-year mortgage and a 30-year mortgage. Now, those who answered true to the question have an average of 56.62 financial well-being score, while those who answered false have an average of 50.98. Again, this is just one scenario, but there was a trend with other scenarios where individuals who actually displayed knowledge, to have knowledge about certain financial concepts, did have higher financial, well-being scores compared to their counterparts. This is a correlation heat map, which I created to kind of understand how the different features that I selected to use, how they correlate with each other. We have the red colors representing higher correlations, higher positive correlations. The blue colors indicate higher negative correlations, and the neutral colors shows no correlations. So to answer my second question, which was about, how demographic factors influence financial well-being, I created a Power BI dashboard. So I said that there was a total number of, the number of participants was 6,394. So that the visuals here, they are color coded. We do have the green color representing financial well-being, which was above the mean. The yellow is the financial being that correlates with the mean, which was 56. And the different shades of red, they indicate the financial well-being score that was below the mean. So you can see from this, from this dashboard that factors such as education, income, an individual's health do contribute to an individual's financial well-being. Now, to answer the third question, which was about, building a machine learning model that could predict an individual's financial well-being, the process that I utilized, so I did split the data set into two sets, with 80% going through the training set. The 20% was used as a testing set. I also did feature scaling, where I normalized the data to make sure that each of the features that I selected had a fair chance of contributing. And then I went ahead and selected the model, which I chose the gradient boosting regressor. I trained the model, feed the model to the training data so that it could learn patterns and relationships. I also did tuning of the model to make sure that, it was performing at its optimal best. And I did that using hyperparameter tuning and also cross-validation. So once I trained the model, I evaluated the model to see if it was effective in predicting an individual's financial well-being score. And I used metrics, including mean squared error, that is MSC, which gave me 100.67, meaning that the model was way off in predicting the actual values. The R squared was 48%. That means it could only give an accuracy of 48%, in predicting. In this diagram, I did plot the two metrics. We have MSC on the y-axis and R squared on the x-axis. So the graph shows an inverse relationship between the two metrics, with 100 being too high. So we are expecting for our model to be working effectively, we need the 100 to be, we need the MSC to be lower and the R squared to be at least closer to 1. So throughout my analysis of the data, I did come up with some key insights, and these include that features such as education and income, they seem to be strong predictors of financial well-being. Life satisfaction and also health, they are positively correlated with financial well-being. Individuals' beliefs and knowledges, they do greatly influence financial decision and outcomes. Again, older generations, they appear to have higher financial well-being scores. For future recommendations, I think this is just a starting point for us to have conversations about our financial decisions, but it's also important that we improve financial education throughout all sectors and especially in schools. We can also promote health and well-being initiatives, not only physical health, but also mental health, because as you have seen, health does have an impact on one's financial well-being. We could provide customized financial advice because everybody's needs are different, but we will also encourage long-term financial stability. So thank you so much.